Hey guys, I'm Mr. Python, and today I'm going to be showing you the first part of my 8-bit CPU. This is one of the most important parts of the CPU. It's where all the logic, addition, and subtraction is stored. There's a way to multiply and divide, but it's a bit more complicated, and I might do a video on it later. It connects to the A and B registers with 8-wire jumpers. This is for data transfer. For example, to subtract B from A, the CPU first gets the data from A and B, and it sends those numbers over the wires in binary. The control circuit will send a 1 on the subtract line, and this will tell the ALU to be in subtract mode. Then, the output of this operation will be displayed on the LEDs. This output number will also be stored in the A register for the next instruction in the program. The reason there are 4 chips instead of 1 or 2 is slightly more complicated. To subtract, you need the 2's complement of the B register. This is done with 2 XOR chips. The subtract signal goes to all the XOR gates and also the carry in of the first adder. The XOR gates are basically inverters with a special input signal. Since the output of the gate is high if one of the inputs is high, this creates an inverter. The other 2 chips are 4-bit adders. They are chained together with the carry in and out pins, and the output of these gates goes to the array of LEDs. There's also an LED that shows if the subtract input is high. This next board is the A register. It can load one number at a time and is used for mathematical operations. These first 2 chips on the left are both 4-bit memory chips. They can be combined to hold an 8-bit number. The chip on the right is a tri-state buffer chip. This chip is used to control the flow of data going in and out. It's called a tri-state chip because it can be in 3 modes, inputting data, outputting data, and blocking data both ways. The headers on the right are data out and data to the ALU. The LEDs also show the contents of the register. The headers on the left are for power, data, and the read, write, and clear signals. The board on the right is the clock. It also contains power headers for the rest of the boards. The USB plug on the top left is for power. To the right is a 555 timer. This timer controls how fast the CPU runs. There's a potentiometer below the timer to control the speed. The 3 switches on the bottom right are also for the clock. The left switch is the manual pulse button, which you can use to advance the CPU one step at a time. The middle switch sets the clock into manual mode and stops the timer. The switch on the right stops the clock entirely. The headers on the left side of the switches are for power and clock pulses. The power headers contain plus 5 volts and ground. The clock headers contain the clock pulses and the active low clock pulses. Active low means the signal is inverted. The last board here is memory. It contains 64 bits of memory, or 8 bytes. The 16 chips near the top left are the memory chips, and the rest are for the control circuit. Like the registers from before, it has a read enable and a write enable, but it doesn't have an erase function. It also has an address line, which is 4 bits, and tells the memory which memory cell to use. The LEDs display the address and the data from the memory. There is also data in, data out, and power lines.